In order to perform the electrolysis of copper-2 chloride, there's a set of materials that will be required. Going from left to right, we will need a conductivity meter, 2 leads, one red, one black, each having alligator clips at the ends, 2 carbon rods, for which we could substitute the replacements that you use for lead pencils or wooden pencils that have both ends sharpened, a Pyrex U-tube, a 9-volt battery, copper-2 chloride powder, a 400 milliliter beaker, and a 150 milliliter beaker. We will use the conductivity meter to test for the conductivity of the copper-2 chloride powder. We will be looking for illumination of the red and green lights at the top of the conductivity meter. Notice there is no illumination as the conductivity meter is placed into the powder. We will now dissolve the copper-2 chloride powder into distilled water. As the copper-2 chloride is added to the distilled water, ask students to make note of the intensity of the color of the solution. In preparation for the electrolysis, pour the solution into the U-tube. Note the illumination of the meter as the solution is tested for conductivity. Connect the black lead to a graphite rod. Place the graphite rod into one end of the U-tube. Take the other end of the black lead and connect it to the negative terminal of the battery, making that the cathode. Take the red lead, connect it to another graphite rod, place that graphite rod in the other side of the U-tube, connect the other end of the red lead to the positive terminal of the battery, making that the anode. Once both leads have been connected to the 9-volt battery, the student should immediately be able to observe that bubbles are forming at the anode, and after a few minutes they should be able to observe that copper is accumulating on the cathode. Students should also be able to observe that as the electrolysis progresses, there is a reduction in the intensity of the solution. The teacher may want to ask the students why the chlorine is attracted to the anode and why the copper is attracted to the cathode. The teacher may also want to ask why the chlorine forms a gas, whereas the copper forms a solid. Caution students about the dangers of chlorine gas. Be sure to do this experiment in a well-ventilated area. Note that if we take the anode and shake it, we will see bubbles leaving solution. And if we remove the cathode, we will observe copper at the bottom.